In this video, we will introduce transactions within the Java programming language. A key service required for robust server-side development is transactions. Transactions can make your mission-critical operations run predictably in an enterprise environment. Transactions are an advanced programming paradigm that allows you to write robust code. Transactions are also very useful constructs to use when performing persistent operations like updates to a database. A transaction is formally defined as an ACID, or automatic, consistent, isolated, durable unit of work. Atomic transactions are all or nothing. They either work or they don't. They're never left incomplete. Some of the attributes are: consistent transactions always leave the system in a consistent state. Isolated transactions execute in a safe manner. They won't fail if other transactions running on the same server are failing. Durable transactions can survive system failures once they're completed and committed. For example, an online sale may involve the following steps: begin transaction, charge a credit card sale amount, update the sale database, update the shipping database, commit the transaction. The transaction can end in one of two ways: in a commit and everything is saved, or if any step within the transaction fails, the effects of all preceding steps are rolled back or undone. Let's walk through some code to understand. Similar to the previous lesson example, we make a connection to the database. Here we have all the properties we need, plus the code to make the connection. Here's where we get our connection. At this point, we have our update string. This update string is going to change our username. Connection.setAutoCommit. This method sets this connection's autocommit mode to the given state. If a connection is in autocommit mode, then all its SQL statements will be executed and committed as individual transactions. Otherwise, its SQL statements are grouped into transactions that are terminated by a call to either the method commit or the method rollback. By default, new connections are in autocommit mode. The commit occurs when the statement completes. The time when the statement completes depends on the type of SQL statement. For DML statements such as insert, update, or delete, and DDL statements, the statement is complete as soon as it has finished executing. For select statements, the statement is complete when the associated result set is closed. For a callable statement object, or for statements that return multiple results, the statement is complete when all of the associated result sets have been closed and all update counts and output parameters have been retrieved. Here we have a prepared statement. That's an object that represents a precompiled SQL statement. A SQL statement is precompiled and stored in a prepared statement object. This object can then be used to efficiently execute this statement multiple times. I would recommend using the prepare statement when you're looping over some kind of DML in JDBC. Once we've prepared our statement with the SQL, we start to send our values to be updated. Let's say we have more logic here that takes place. What if something went wrong or a certain result was not according to the business rules? At this point, for any reason, if we wanted to roll back the changes that are about to be committed to the database, we can simply throw an exception, which will then skip our commit method and enter us into our catch statement. Here you notice the commit statement. The commit method makes all changes made since the previous commit rollback permanent and releases any database locks currently held by this connection object. This method should be used only when autocommit mode has been disabled. If we do throw an exception in here, once it enters into our catch block, we find the method connection.rollback. This undoes all changes made in the current transaction and releases any database locks currently held by this connection object. This method should be used only when autocommit mode has been disabled. Let's run our program. and let's see what happens. Here we're setting all our values, and here we're committing. But immediately after, we're throwing a new SQL exception. Will the data commit? Let's see. First, we can take a look at our data source. Here we have the values in the table: ID 1, name Bob, and password. Let's see if our program changes that. I right-click on the source, run as Java application. We successfully connected to the database, but we see here that transaction is rolled back. Why? We can see that our effort to change or update our user has been aborted and rolled back, leaving the integrity of our data intact. When the exception was thrown and entered into our catch statement, connection.rollback made sure to roll back any changes that were made in this prepared statement. This concludes our discussion of transactions in Java.